Well, welcome to the December 7th, 2021 session of Tangerine SDR in Ham Sci Technical Session. My name is Dave, KB0S, and this week, actually, I've been doing a little bit of forestry publication work, reviewing um, proofs on a book chapter that had worked on. So that was that, and a few other little projects in the works, but nothing definite yet. So next on the list is Nathaniel, W2 NAF. Go ahead, Nathaniel.
Thank you very much, Dave. Let's see. Just continuing to try to wrap up the semester here. I think things are going along fine. I submitted my AGU presentation last night, so that's all posted. And we're trying to just get ready for the American Geophysical Union meeting next week, which is going to be hybrid. So I'm planning on going in person to down to New Orleans, and then Jules and Joe and a few other people here have virtual posters. Hyomin, I think, is going in person, so I'll hopefully see him there. And I think that Dev is going in person. I think that's about it. Later this evening, we might want to talk about Joe's poster. Actually, a number of us are co-authors on there, so I think it's still, I think we need to do a little bit more work on that poster. So maybe we can all chat about that a little bit. So W2NF back to now.
Fine business. I'm going to go ahead and call on Robinette, just to give you a chance to talk since you said you would be leaving shortly. So,
oh goodness. Okay, well, I guess
go
I
ahead.
could repeat. Okay, if there are more people here, I'll briefly just say that what I said earlier is that we have uncovered what appears to be some data loss in the whispernet.org spot database. And we're doing deeper investigations into that. So hopefully we'll be able to share a kind of a review or analysis paper that's being prepared by Gwen, G3ZIL, my colleague and partner in this a Whisper Demon project. So that was what this seems like the most useful thing. I've determined that as part of this analysis, we appear to have established that approaching half of the Whisper spots being currently submitted to WhisperNet are coming from Kiwi SDRs, and most of which are running my software, Whisper Demon. So if this is, if there's a forward-going interest in other analysis than what we're doing, we are just recording spots. We are also recording the background noise levels to our database, but we could run other analysis on the recordings, the WAV file recordings we're getting. And if in the future anyone sees that something of interest that they'd like to do, it would be pretty straightforward for us to add that feature to the software, and you would find it widely deployed worldwide within a few weeks. I mean, I'll be doing regular software and feature upgrades on Whisper Demon, and so we have stations worldwide from Maui to at least Moscow are running it. And there are many of the top spotting stations worldwide. So not only are there many stations, but they're also contributing. Almost half of the total spot database is coming from them now. So anyway, it's an opportunity for a researcher who had some other insights they might have. Contact me, and we could discuss how we might enhance Whisper Demon to do more than it does now. Anyway, that's my subject for the week.
Okay. Well, thanks for having it. I wanted to give you a chance to get to you before you took off. So next on the list is Bill, AB4EJ. Go ahead, Bill.
Hey, Dave. Dave, you might want to turn your mic gain up a little bit. It's pretty low, but uncharacteristically for me, a negative traffic tonight. So back to net.
Oh, okay. And next on the list is Bill in 8ET. Go ahead, Bill.
Surprised me there with a short one before that. Got my mouth full. I don't have too much this week. I got with all the projects I've already got on my bench. I got one more in. I'm not sure when I'm going to take care of it, but I wound up getting a K2RIW kilowatt amplifier for 432, and that's down on the bench now. It's been in storage for 40 years just south of me in the barn that somebody's cleaning out, and they brought it up and dropped it off. But that's about it for me, and sit and listen again tonight. Back to you.
Well, fine business. And next on the list is Dan in 4XWE. Go ahead, Dan.
Good evening, Dave, and hello, everyone. Actually operated on the air live this last week. I did about, I thought it was about 15, but it was actually 28 contacts on FT8. So that was actually quite a bit of fun. So I may do that again. Back to you, Dave.
Very good. And next on the list, let's see, David Waugh, KE8QEP. Go ahead, David.
Hello, everyone. I'm still working on characterizing the 60 hertz noise. It's in my backyard. It's going a little slower than I would hope, but I think I'm making some progress. I guess that's it. Back to you, Dave.
Okay. And next on the list is Dev, KC3PVE. Go ahead, Dev.
Hello, I'm doing all well. Everything is going very well. Thank you.
Okay. Next on the list is Gary, AF8A. Go ahead, Gary.
Yeah, good evening, everyone. Just sitting here listening in, trying to keep current with the activities. Back to net.
Okay. Next is Hyomin Kim, KD2MCR. Go ahead, Hyomin.
Yep. Good evening, everyone. Yeah, as Nathaniel mentioned, yeah, I'm preparing for my presentation at AGU, American Geophysical Union meeting down at New Orleans. I'm going down there in person. So this is going to be my first in-person meeting since the beginning of the pandemic. So,
Hyomin and I are gonna party it up.
yeah. Otherwise, yeah, I've been still working on some ground-based magnetic field responses to external drivers such as solar wind, so that we can sort of estimate a certain frequency of the magnetic field. You can imagine that as a kind of guitar string. So each different field line that is connected to certain area has some eigen frequency. So you can measure it, you can observe it, so that you can actually estimate how the magnetosphere behaves in the context of frequency. So that's what we are doing, and hopefully I can relate that to this HAMSI project. So that's what we're trying to do. Otherwise, there's not so much to report. Back to net.
Okay. Next on the list is James, KG4DSG. Go ahead, James.
Good evening, Dave and group. Not much to report here. Back to the net.
Okay. Next on the list is JB, K8OS. Go ahead, JB.
Hello, everyone. I hope that your weather is nice and warm because it's winter here. We got our first snowstorm, and I was out laying radials for my new 160-meter inverted L right after it snowed. So anyway, I got that job done. But more to the point here, Dave Larson, Dave Witten, and myself have been discussing a DSP client, building a DSP client that will accept IQ data streams for from whatever radio we choose. Your radio, of course, this radio. But the idea is to assemble buffers of arbitrary size and perform spectral transforms of one type or another. And we're going to start with FFTs using GPUs. We've all assembled Linux boxes for this purpose. And right now I'm sketching out the code, the backbone of the code to do this. Initially, we'll talk to an RTL SDR, but the idea is, of course, that we talk to this radio and we do these functions. And it's designed to be extensible. We'll be able to do spectral transforms of arbitrary size, first starting with a full complex FFTs using the NVIDIA's CUFFT library. And then later, at some point, when we get tired of looking at FFTs of these spectral transforms, I will write a library for wavelet transform so that we can look for phenomena with a given, well, mathematically, it refers to a tiling in frequency and time. And so we will be able to look for phenomena like that. At any rate, we're very early into this, and I'm going to let Dave talk more about it.
Okay.
Back to Ned.
Yes, we are participating on this, and it's exciting work. Next on the list is Jim, K4BSE. Go ahead, Jim.
Good evening, all. Not a lot to report. I've been a chauffeur and Sherpa for my wife who was injured in a fall. And so she's back to her normal activities, but she can't drive and she can't carry anything heavy. So guess what I do? Let's see. On this, I continue to find a little bit of a problem with FL Digi changing frequency occasionally on me. I could swear that I'm not doing it. In fact, sometimes the time that it changes frequency is when I'm not even in the shack. So I haven't quite figured out what's going on there. I am running off of a UPS, so that should take some issues off the table. So I'm still investigating that a little bit. However, this last week I did get this TAC reel-to-reel tape recorder I've been working on. I've got it running in both record and playback now. Back to Ned, this is K4BSE.
Okay, I noticed I jumped over somebody, so I'm going to call on Dave, KD0EAG. Go ahead, Dave.
Not a huge amount to report here. Yes, met with JB and Dave Larson about some alternative analysis code. Just experimenting with that, and I have probably spent more time trying to, working with Amartya, getting him up to speed with the magnetometer stuff, try and get him to where he has at least a minimal working setup and understand some of the concepts so he can explore something useful for us. And I seem to spend an awful lot of time on either Zoom or WhatsApp or something, also handling traffic between LA and Eastern Europe, trying to do family things and trying to do some absurd things, but keeps me busy, but not all related to this. So that's it for me.
Well, fine business. And next on the list is Joe, W7LUX. Go ahead, Joe.
Good evening, everyone. Yeah, winter weather is about to arrive here also. We're expecting maybe rain and snow tomorrow, and then snow Thursday into Friday. But spent a fair amount of time putting together a presentation for AGU and sent it off to Nathaniel.
Very good. And let's see, next on the list is Jonathan, KC3 EEY. Go ahead, Jonathan.
Hi, everybody. I had a fairly busy week. I finally figured out the actual problem that I was having with my timing system. It wasn't the software. It wasn't the driver. I didn't have to lose all my software for it. But I finally figured out after I did replace the cable, which did need to be changed out because the plug was definitely bad. It turns out to be the Trimble GPS receiver. What would happen is during intermittent times, the leading and falling edge would jitter a little bit by about 1.5 milliseconds each pulse. It would kind of jitter back and forth, and the timing software is expecting the rising edge to occur about a second after the last one. And if it doesn't see it within that window, then it'll miss it and it will not adjust the timestamps. And that's the problem that I've been having. Originally, I thought it was something with the sound card, but it turns out it was something with it's something with the GPS. And I was thinking about it, and I was talking to some people, and and one culprit people say is that it could be the antenna cable. I did move the puck antenna that I have. The wire has been like compressed a little bit, but no major damage. I know that can matter, but with the kind of jitter that I was seeing, something was definitely wrong. So I contacted an application engineer at Trimble. He was also stumped. So what he told me, he said to do a factory reset using the Trimble software, upgrade the firmware to the latest. The latest is version 1.8. I'm running version 1.5, and then do another factory reset. He said that version 1.5 was not shipped with the units, that it had to be upgraded somehow in the field. So I don't know if the distributor did the upgrade or not, and if they did not do a factory reset, then he said that there's a possibility that there could be some undocumented anomalies that could happen without the factory reset. Other than that, I'm completely stumped as to why it does this. And the interesting thing is, if you unplug the antenna cable, after about 8 seconds, this jittering goes away and it works as normal, like it should. Obviously, it's running in holdover mode using the onboard oscillator, but so I'm going to upgrade the firmware, and I'm going to see if that makes any difference. Another thing that's worth mentioning is the Trimble Res 720, the L1 and L5 GPS receiver that has the spec of 5 nanoseconds accuracy. That's finally released to the public beyond engineering samples. It's the module on a carrier card is $213, and there's also a L1 L5 antenna also that you can order. It's not in stock yet, but you can order it. And lastly, the cable gland that I used on my VLF antenna, it's not big enough for Cat 6. So I just went on DigiKey and ordered the next size up, which is big enough for Cat 6, because the Cat 6 has to come through it, and a small ground wire. So I ordered that for the antenna, and hopefully I should be installing it soon. That's all I have. Back to the net.
Well, fine business. And next on the list is Jules, K2KGJ. Go ahead, Jules.
Okay, we're unmuted. Number of things this week. First of all, I'd like to welcome Noel Pettit, who's here, who is actually has an installation in the ground with both an RM3100 magnetometer and a single axis FLC 100 by Stefan Mayer, which is the single axis version of the FLC 370 that Hammond has. And he's been collecting data with that, but he's here to talk about other things regarding an upcoming radio conference and a possible presentation for magnetometers there. This week, I've been continuing to work on getting my FLC 100 3-axis ready, including some low-pass filtering and testing some different ADC converters. Managed to break away some time over the weekend to participate in the ARRL 160 CW contest. QRP made 162 contacts in 36 sections for the time I was able to participate in that. That's about it here for the week, and back to Annette.
Very good. And next on the list is Mike, AA8K. Go ahead, Mike.
Oh, thank you, Dave. I'm capturing eclipse, post-eclipse data. I use CHU because it's closer to me than EEWV. Greetings to everyone listening. Back to you, Dave.
Fine business. And next on the list is Noel Pettit. Go ahead, Noel.
Okay, well, welcome and thanks, Jules, for the slight introduction, the start of the introduction. I'm located in Harris, Minnesota, which is the first evenly numbered exit north of the Twin Cities in Minnesota. I'm giving you all the trivia, so you don't have to worry about that. It's 3 below 0. The wind chill was below 10 below almost all day. And this is where winter comes from. I have, for the past 10 or so years, we've had a magnetometer from the old Falcon system, which was a UCLA project run by Professor Chen. And we then have started up the SMART magnetometer program in an attempt to have low cost and multi-site magnetometers running at schools and those kinds of things, which is why we've gone to things such as the RM3100 and the FLC 100. I put on the chat the link to my Adafruit IO site, which has my dashboards, which is where the live data is playing. This data is now being looked at by UCLA students in the SMART project, and we are starting to get old magnetometers that have been around the nation, around North America, get them running again. And so we have about 6 of the old, the traditional fluxgate magnetometers running, which is what you'll see as the Falcon magnetometer on my dashboards. And we have those up and running. We've been able to find the faculty members and provide them with new hardware and software, and those are running. Those magnetometers then we hope to add to those using the FLC 100 and the RM3100s. And so that's why we can see the comparisons between those. Right now, the magnetometers are buried in the front yard down the hill. Yesterday I could have gotten them out of the water, out of the hill, but it's too late now. They're 40 inches down in below the frost line, and that's where they'll live for the next 3 months or 4 months or so. So that's what we're doing, and worked with Hoyman Kim and a number of other of you, and also work with Mark Engelbretson, who's running the MAX program, which is a magnetometer array basically around Hudson Bay. So anxious to hear how things are going with your other magnetic field instruments, and anxious to hear if you have any ideas, which Jules has given us many, for working with these lower cost magnetometers.
Very good. So next on the list is, we've talked to Rob. So Scotty, WA2 DFI. Scotty, you're back.
Yes, I'm back, feeling much better, and sitting by the ocean here. It's not quite -2 degrees. It's a mere 68 degrees here in Phoenix. So it's about 80 degrees out today. So this is a few times a year I get to gloat over the people up in Minnesota. And but when in summertime they can tell me that it's 70 up there and it's 110 down here. So that's a paybacks, you know. Still working on the
No, get a rope.
yeah. Yes. So we have a good militia down here, so come on down. Anyway, working on the adapter board still, and trying to find any FPGAs I can. Turns out that we're entering the fight zone with our distributor because they seem to have lost our order. And now when they put our order back in, oh, guess what? You're not in the queue up there anymore. You're in the queue starting now. So we're going to have to figure out something to take care of that problem. At any rate, I'm really interested to hear in Noel's comparison of the 3100s with his more robust or more expensive magnetometers that he's using, to see how we compare. Do they look like they track? How is the sensitivity? That's probably our most important thing, is the sensitivity. So that's it. Back to you, Dave.
Well, fine business. And next on the list, we have Todd 80RR. Go ahead, Todd.
Thank you, Dave. Yeah, I'm still running my Grape one in the DRF configuration. And so that's the data that I'm going to be sending for the Eclipse party coming up here soon. And yeah, winter is setting in. And so I've been putting off getting a hole dug for the magnetometer. We live on a plateau in the Ozarks here with cursed topology. So a post hole digger, a breaker bar in 3.5 hours got me 26 inches down. Yeah. So anyway, so I've got an open hole sitting there. I'm waiting for some I2C extender boards from SparkFun, and then maybe I can get something in the ground and start collecting data. So anyway, that's all I got. Back to you, Dave.
Yep. And next on the list is Tom McDermott in 5EG. Go ahead, Tom.
Oh, good evening, Dave and the group. Real quick week here. I put together a short email to Bill and to Scotty about some changes to the LHDE protocol, pretty minor. Other than that, nothing else going on. So back to the group.
Well, as far as I can tell, I haven't jumped over anybody, and we've got all the people. So barring any notes, we're open for general discussion.
So Tom, when was that email?
I sent it right after the meeting last week, and it's just a pretty minor change. The reading of the ID prom contents is a little ugly, and so I suggest just returning a 9-byte message instead of 9 1-byte messages, and then writing the driver so the driver will read the prom with a single event.
Okay.
Yeah, I received it. I got it. Thank
I
you.
didn't get it. I didn't get it too. And I was thinking that what we would do is we'd have the FPGA in the final implementation. You have the FPGA just read that constantly and keep some memory locations updated, because remember, it can do everything in parallel. So that takes basically nothing away from anything else. And then when you query it, all you're querying is memory locations.
Yeah. So basically, the protocol we have for module reads and module writes is by design, and it's kind of weird how the ID prom reads stuff. You have to go out and wake up the chip, and then it's got some particular addresses. They're non-contiguous within the memory space. So anyway, I figured, at least for the test system, I'm just going to hard code all that into the C driver that's running inside the FPGA. So the protocol can just issue a read, and the code inside the FPGA will just take care of it all and return a 9-byte message.
Okay, sounds good.
Just a quick comment. Noel, could you give a little background on that conference that's coming up that you emailed me about earlier?
Yes, yeah, let me look back at it. It's in March sometime. How does this computer work? I'll figure it out. The QSO Today Virtual Ham Expo, which is going to be in 12-13 March. I think our smart people will want to talk about something like that. Do we want to tie that into HamSci? I know we've had HamSci things in there before, but I just wondered if anybody had any thoughts on putting that together.
I haven't thought about it too much yet. I have been thinking a lot about the HamSci workshop, which is the weekend after. So the HamSci workshop would be March 18th and 19th. But if there are people who do want to do some HamSci type of things for the QSO Today Expo, that would be really good.
Yeah, Nathaniel, I will talk to our smart people. This is the new UCLA group. And we have a couple of people that are designated for outreach only. Basically, they're going to do all the outreach of anything we're doing to try to bring more schools in. And I will talk to them this week, and then I'll send you a message back and see what kind of interest we had. But yeah, we need to present at all these kind of things to try to keep people up to date on how much progress has been made.
Yeah, definitely.
Yeah, I was planning on presenting there on the status of the hardware. We should have boards by then, hopefully. But it won't be specifically on magnetometer stuff. So, and I'm envisioning once we get the hardware, we're going to kind of migrate away from constant reports on the hardware and end up with more reports on what the software is doing and how we're collecting data and how can new people be involved, that kind of thing.
Right. What we're doing right now, well, the data that I put up was from Adafruit, and they only keep a month worth of data. I keep everything on the Raspberry Pis, but we're also starting to put everything over on a Google storage site. So we have these 6 magnetometers all passing their data to Google so that we're getting people, more people interested in seeing what that data look like.
So how are they comparing to the high buck magnetometers, the 3100?
Oh, they're very equivalent. The only real problem is I don't have them lined up exactly aligned with each other. Minnesota, besides being incredibly cold, has a variance of 0. And isn't that what dead men vote? No, it's deviation of 0, right? The dead men vote twice, right? Everybody remembers that deviation, magnetic variance to true, right? All you old Navy guys remember that.
I thought you're talking about Chicago.
No. They much more than twice, but it's dead men vote twice. Anyway, okay. We're right line. We have a 0 we have a 0 deviation, and so it's hard to get close because I've got one. Well, the flux gate, the good flux gate is running on one side of the 0, and all mine are running on the other side. So it's hard to get them exactly lined up. But if you look, you can see the graphs are basically the same. The noise of the 3100 runs 2 to 3 to 4 nanotesla, and the flux gate runs maybe 1 nanotesla noise.
So the problem is that trying to measure 0, you end up with not a very good measurement. Is that the problem? Trying to measure very low values.
Yeah, but do we care about what the absolute values are?
No, I don't think so.
No, we're just variometers anyway. Yeah.
Yeah. We don't really care about what the absolute zeros, where the absolute zeros are. It's just a little easier to compare them when they're lined up exactly. But we're close enough to the North Pole. Well, I think it's just across the street here. That everything's in the Z.
Just seems like it is when it's 2 degrees out, right?
Right. Yeah, it's 2 degrees.
2 degrees is balmy up there.
Yeah.
It's balmy. Well, it's t-shirt weather finally.
T-shirt under snow parka, you mean?
Yeah. Yeah.
See, in Arizona, you can always tell the Minnesota people because when it gets above 40 degrees, they come out in shorts and t-shirts.
Yep.
And we're
Yep.
still wearing winter coats because, you know, we're wusses down here. So it sounds good. So it sounds like that's compares favorably then for.
Yeah. For considering the price difference, there's not much difference in since most of our daily variances, the daily variability will run 30, 40, 50 nanotesla in any one of all three axes. We don't lose much. And then now if you could just get the sun to get back to it again so we can see something. Yeah, take a look at the graphs there on the chat. And if you have any questions, you can get to me through headed at augsburg.edu, augsburg.edu.
Let's see. I was wondering, Joe, would you want to show what you've done with the poster so far, and maybe we can chat about that a little bit?
I'm totally confused on what you expect. You had originally told me to do a presentation, 15-minute presentation, and then it changed to a poster, and so I'm kind of lost on what's going on here.
Yeah,
but, I can show what I came up with, but you know, I'd actually worked on doing a live presentation or a recorded presentation with the showing a couple of slides about the grape and a couple of slides about radio communications in general and a little bit on results, but I haven't seen any analysis at all.
Well, Veronica has been working on analysis, but she's working on the analysis that's like a general algorithm that's eventually going to get applied to the data from these other stations. But that she has a presentation, an oral presentation on that. But it's not at a point where she's ready to apply it to like every station yet.
Okay, well, Steve and I did some timing type stuff, and I've refined the reception of WWV, got it down to better than 1/10 of a millisecond. And trying to figure out the height of the ionosphere. I did some calculations on the stuff I came up with, and 1 hop would tend to indicate that the ionosphere was up 180 miles from some stuff that oh, come on. Your other grad student starting with a K, Katrina, is it?
Christina.
Right, Christina. Okay.
Yeah.
She sent me some information, and it's either 1 hop, 180 miles, 2 hops, 90 miles, or 3 hops and 60 miles. And I think 180 is probably a little bit too high.
And altitude?
Altitude, yeah. Isn't it up about 100, 150 kilometers?
So the E region would be up about 110 kilometers, and the F region would be up around 230 to 250 kilometers.
Oh, then 180 is not totally out of the question.
No, no. Yeah.
Okay.
That's 290 kilometers. It's a little high, but
But
is that a slant?
We get back on here. Anyway, I was going to talk about that, and now I guess I'm going to modify things for just a poster.
Yeah, it has been a little bit of a moving target, and I apologize for that. So yeah, we do have it is a poster presentation instead of an oral. Would you rather should we try working on this offline later in the week, just you and me a little bit?
I think the posters are due tomorrow.
Well, so that we have to have them they have to be published by tomorrow, which means people can start looking at them, but you're able to keep making changes to it until the actual poster session. So
maybe even afterwards.
Yeah, and even now, yes, that's true. Actually, last year I ended up doing that. I ended up like working finishing my
Well,
poster after
what
the
would you
photo
like me to
is.
do at this point? I've sent you what I have.
Mhm.
And you seem to think that a different approach would be better. I was just going to tell people what we've done, how we've done it, and here's some very preliminary results.
Yeah, I think I think we need a few more words on the poster to make it kind of stand on its own. I think that's one of the places where it needs a little help, because people are going to be able to look at this poster and read it without you actually being there.
Okay.
So that's where I was trying to get like a little bit more of a story. So if we could actually put a few more words in there, and so it would stand on its own without you actually having to say anything.
Well, I'm not sure about a story, because you'd ask, putting together a grape, and, I got a bunch of parts, and got a picture of all the bags with all the little parts in them, and didn't take any pictures. There's nobody here to take pictures of me working on things. And probably wouldn't have done it anyway. But this was done back in the spring.
Yeah. Well, that's what I was wondering. Maybe, do you think we might be able to ask some of the other people if they would have some photos that would, well, you did send me some of the photos of your grape as well in the Word document.
Yes. Yeah, those were all of the images, pictures that I intended to show while discussing what was happening.
Yeah. Did you put those into the actual poster?
No, I put, let's see, 2, 4, 6. I put 6 images in there, 2 on each side and 2 in the middle.
Okay.
And that was see, what I had planned on is that poster was going to be an introduction. And I will use that as an introduction if I present this to the local radio club. That's the first one. And then from there, go into the fact that John, go into how we get Doppler measurements, and that John put together an idea for a receiver, and provided schematics and part list and printed circuit boards, and then put one together, and here's the results.
Yeah. But for the AGU meeting, the poster shouldn't just be an introduction. It should be its own total presentation.
Well, yeah, I didn't understand that until just very recently.
Yeah. Maybe we can, maybe I can meet with you later this week, and I can try and look at it with you a little bit more before next week.
Okay. Sure. There's always email.
Yeah, I'll go over with you by email.
Okay. What do I have to do about getting a poster at least somewhere published? Let me see if I can bring it up here real quickly.
And Joe, if you need any photos, Bob Benedict, I can't remember his call sign. We did a presentation. I guess it was an oral presentation for Tapper, but we have photos of our grapes, and if you need any photographs, let me know. I'm happy to share them.
Okay, I've got.
I think that might be nice, David. And you're actually a co-author on this poster. Believe it. We put this abstract in. We put this abstract in about 6 months ago, and I think on a Thursday morning we all said, "Okay, this will be a good idea for us to do." And
well, I've got almost 24 pictures, and there's no way 24 pictures are going to fit on a slide. I mean, a poster.
oh no, they absolutely, with this one they will. It's just you have to click on the columns. If you bring up the poster, I can show you.
Okay, I've got the poster right here. And how do I share my screen? Do a share screen and
should
share.
be a little, yes. There you go.
And let me move it over here a little bit. And
right, so that's that's just a screenshot of the poster, but that's not how people are actually going to be looking at it.
Okay,
so
well, see, I don't know anything at all about that.
Right. So if you go to the AGU website, where do you go? Are you able to get to the place where you edit this poster?
Not right now. I'd have to bring it up. I have to find it and bring it up.
Okay. Let me, because if you do that, then I can, if you can bring that up maybe in a few minutes, then I can show you how this would work.
Okay, how do I get rid of the stuff on the right? Okay, well, it's going to take me a little while to find that.
And I can show you an example of a poster I did last year.
See, I've never seen one of these posters before.
Yeah, they're a little bit different. So this is what we call an eye poster. So here's mine from last year. So in any single one of these columns, you can have more than one figure. So like in this second column right here, I've got 1, 2, 3, 4 figures. And if you click on any of them, they get bigger. You click on that column comes up larger, so you're able to read it easily. So you can really fit many. In this first column, I have 1, 2, 2 figures, a table, another figure. So I've got 3 figures and a table in that, just in that one little column there.
Okay, but you're asking somebody who's never, ever done a poster or even seen posters at a professional presentation or professional symposium.
And that's why, if it's okay with you, if you'd share it with me, like I'll work on this with you, or I'll do it, or I can get some photos from David and I can help build this up for you to
Okay.
where I think it would look good.
I did send you the link and everything. Let me see.
I think to actually share the.
See, right now, the stuff from this meeting is taking up my entire screen.
So if I stop,
Oh, here we go.
I can stop my screen share.
Okay, here we go.
All right,
So I can close this image maybe and find where. That's not what I want. Shall we do this and let everybody else run off and do other things?
Yeah, we can do this another time.
Or well, whatever's convenient for you.
Or we can do it after the main meeting. Yeah, if it's okay with you, we can just turn it back over to the regular TangerineSDR group, and then when they're done in about 10 or 15 minutes, then we can go off to a breakout room and work on it.
Okay, well, I can find bring up the poster section. It's going to take me a couple of minutes to find it.
Okay.
I have a very hard time getting around that AGU website.
Yeah, I know.
There's the 24 slides that I had intended to use. Where the heck are my URLs?
Yeah, Nathaniel, this is Jules. When I was uploading my slides, I found that when I chose I think it was a 5-column presentation, that would load the slides in order. I tried a 4-column and they were running in and backwards. In other words, if I loaded slide 1 and then slide 2 would appear before slide 1. But when I went into the 5-column presentation, everything loaded beautifully.
Well, that doesn't make a lot of sense, but
I
I'm
know.
glad you figured that out.
Yeah, it took me a while to do. I made 4 or 5 tries at it before I figured what was going on.
That's weird. Yeah, and I saw your thing about the no response from like you haven't gotten any response from AGU.
No.
They're probably just overwhelmed.
Yeah, I thought I'd try calling during the day tomorrow.
I think that's a good call.
Yeah.
Because I don't think there's anything I can do without them.
Right. No, I just wondered if you had other contacts within AGU, but I'll give the desk a call tomorrow.
Yeah, I think my one contact is like can help you with the registration,
Mhm.
getting the free registration, but I don't have. I mean, the technical support contacts would be the same technical support contacts you have.
Right. And it is apparently a technical problem because I am registered.
Right.
I did post it and it just won't let me publish it. Just says I'm not registered.
Yeah. On the plus side, they seem to be pretty good about, saying, they won't say something like, oh, you didn't make this deadline or something like that. They'll be like, okay, sorry, there's a problem. And I think they'll just fix it. I think there's still a lot of hiccups and a lot of unknowns with this hybrid format because, last year, I think it was pretty much all virtual. And this year's the first year they're doing a hybrid format, and people they're asking us to do things we haven't done before. So we're not very comfortable with the format. And the other thing that's really weird is, I'm planning on going virtually, but I know other people, I'm planning on going in person, but I know other people who were planning on going in person now have decided they're not, and they're going to go virtual. And so I'm going to have to go down and share some sessions, and we'll do the best. We're going to do the best we can.
Nathaniel, I just remembered I cannot access that site on this computer.
Okay. Well,
So,
I might be able to access it because I have your password. So
yeah, you've got the Nova email
Yeah.
address and the password.
yeah. So
But I forgot, this is an older computer, and whatever they have there doesn't like it very much. I have to use the Win 10 system to get on there.
yeah. And David, wow, if we do ask you for some photos and some input, I might take you up on that offer.
Okay, yeah, no problem. Actually, I'm just trying to find our PowerPoint we used, and I can send it to you.
That'd be great. Thank you.
Yeah, the other thing I did from the PowerPoint, I just published each slide, or rather I exported each slide as a PNG, and then it was trivial to load them.
What did you say after you exported as PNG?
Oh, I said I had an original PowerPoint, and what I did, I couldn't upload those slides individually or as PDFs.
Oh,
However, the site accepts any graphic like a PNG or a JPEG or a GIF. So what I did was basically exported each slide one at a time as a PNG, and then I used that set of slides to upload to the iPoster, and it worked beautifully.
Okay.
Yeah.
Well, all of mine are in either JPEG or GIF, not GIF, but PNG or something.
Yeah, that they should accept that. In fact, that's the only format they'll accept.
Yeah.
The graph is the image format, right?
Yeah, I got that. I understand that.
I got in, Joe.
Okay.
So here it is. So if you hit preview right here, this is what people will actually be seeing. So when they go to it, they'll be able to click on one of these.
Right.
And they'll be able to scroll through and see each image and read the text.
Well, what do I do? Just keep adding more images?
You can do that. I think the thing is we want to go back to what we actually originally wrote in the abstract. And I have that up here.
Oh gosh, I've got it somewhere.
I have it. It's on the online program too.
I've got it here too.
Here it is. So here's the title: Construction Operation of a Hamside Grape 1 Personal Version 1 Personal Space Weather Station in a Citizen Science Perspective. Yeah.
And that's what I did.
Right. And so let's just see what the abstract is. Measurement of Doppler shifts of HF So in this presentation, we explain the process for constructing a GRAPE version 1 and discuss the experiences of volunteers who have built and are now operating the system. We also discuss preliminary data from this stations, which shows dramatic Doppler shifts during sunrise and sunset and during solar events. Concurrent data from multiple proximal stations show shared features and can be used for validation. These stations constitute the first iteration of the personal space weather station network.
Right, and that's what I did.
Right. So, but I think, well, I think what we could still use some more of though is, I think we can use some more of what explaining this process for building one of these and some of the experiences in building it.
You mean like the that little ESD thing turning into a jumping bean?
What was that? The
ESD part, the one that's about the size of a flake of pepper, turning into a jumping bean.
Right. So some of those things, it's like
I've lost what 2 or 3 of the 4 I ordered.
Yeah. So I mean that's part of it.
I mean, what is there? I mean, either a person understands surface mount construction or they don't.
But I think, well, I think for part of it is, you know, walking through the fact that you can go to hamside.org and we have the
I mean,
instructions here.
Several of the images I sent you have, you talk about John and a schematic, and he drew up the schematic, and then he prepared circuit boards and bill of material lists and where to get them, how to get them, which is probably getting pretty hard nowadays.
Right. But that's the sort of thing, that I think can go in the poster.
Yeah, and Joe, also what your personal experience with it is kind of adds interest as well. That's kind of what I tried to do.
Exactly.
No, I focus more on the equipment and results than I do whatever. I mean, yeah, there was some colorful metaphors generated when the surface mount device didn't stay put. But hey, the first one worked, the second one worked, and I've lost the printed circuit board, misplaced the printed circuit board for the third one. And that's the April 25th image. I've also got yours and I think John's plots for the same day on another slide or another image. I've got that in a quiet day. I got a quiet day, and then I've got 3 of these example of daily Doppler shifts. I concentrate more on getting the thing running and then getting results.
Mm-hmm.
But okay, well, whatever. I really don't know how to add more images. I thought I could only stick 2 on there, and they turned out to be pretty compressed.
Yeah. No, you can definitely do more than 2.
Yeah, I'm gathering that. But we've got WWV sending them, and that's a beautiful tick in that one time of flight measurement. And that shows the 3.4 millisecond time of flight between Boulder and here. And then there's another one that blows it up by a factor of 2.
Which one are you? This one over here?
Yeah, the measure the time of flight. That's one of their ticks. And then the little vertical line just to the left of that, and right above where the blue trace is the 1 pulse per second. That's on time. That is within nanoseconds of the 1 pulse per second. And the grape receiver has almost no delay. It's down in the nanoseconds or less than a nanosecond of delay. So you can measure from that little vertical line out to the, say, the second crossing and get 4.4 and then subtract 1 millisecond for using the second crossing, come out with 3.4.
Right there.
And I asked Christina for some ideas. She sent me some a very simple form of figuring out the height of the ionosphere.
Yeah.
Yeah, throw that in.
Yeah.
So, well, is this good enough to send them? And then what do we do tomorrow? Something's due tomorrow.
Yes, I mean, we can do it right now. So the thing that we need to do right now is all we have to do is hit publish.
Okay.
And then that will at least satisfy the requirement for tomorrow.
Okay. Either you can do that or I can do it, either one.
Yeah, I just did it. And then we still have so now we've met our deadline for tomorrow.
Okay.
But now we still have some time to work on this a bit. See, I think it would be better if we put in some sort of introduction, like a motivation up here. If we included some a more detailed description of the parts list, of what the schematic is, what you actually had to do to build it, and like Jules said, to include some personal experiences of even things like what challenges did you have any challenges with antenna placement, or did you have any issues with system reliability, or did you have any issues with interference from other systems at your station that you had to figure out? Stories like that might go in well. And then have some of these results over here, and even like this can probably go into there. So you have like results up here, and then maybe we do a little summary box in the corner here.
Now that you mention it, I did have trouble with signals from the local GPS DOs. Not GPS, but the local frequency standards. I've got 5 and 10 megahertz frequency standards here.
Right, like I think that would be an interesting thing to put into the poster.
Yeah,
and then how did you deal with that?
Disconnected them. I just can't use them when receiving this. And the other problem is sharing, because it's using my 80-meter dipole, which is a full size dipole cut for about 3.6 megahertz, and it's up 40-50 feet up in the air.
Yeah, and that's also something you could write in.
So yeah, that's somewhere in the stuff I sent you in the Word things. Okay.
Well, I guess what I'm asking from you too is like, so I don't want to. I definitely, as you can tell, I definitely have like some ideas and suggestions, but at the same time, I don't want to like totally take over your poster since you're the first author of it. So like, I want to be helpful, but I also don't want to I don't want to overstep my bounds, if that makes sense.
Well, I've never done this before, so I probably need some guidance.
Okay, if you don't mind, then would you mind if I tried my hand at reorganizing, restructuring it a little bit and working with your material?
Okay, let me know when you need more verbiage.
Okay.
And or more words.
Yeah. And would you mind if I got some more input from, say,
no,
David Wow?
No, you're welcome
and
to
you're
bring in anything you'd find appropriate.
okay. And David, are you okay with that too? You're a co-author and
Yeah, I'm happy to help as I can.
okay. So I will try to like I'll try to like restructure it, and I'll start working with the material that Joe sent, and I'll try to put that in, and then I can share it with you guys, and I can be like the integrator and try to get it more into a format that I think will be well received by the AGU community.
Because what this initial slide that we're looking at, or image we're looking at, was just simply an introduction. And then all of the other images I sent you were going to be, proceed from here. And in fact, they use many of these. In fact, I think they use them all.
Right.
Describing these for things that first showed up here. I was really surprised when I saw that I couldn't fit 2 images in one box, or one column, I should say. Again, this is totally new to me.
Yeah. No, I understand. I mean, if you've never done this sort of thing before and you haven't seen these posters, I mean,
No, I've never seen one
absolutely.
before.
Yeah. No, it is definitely it's a different sort of a
It took me a
beast.
while to figure out how to even do this much.
Yeah. No, I believe it. I really do believe it.
But anyway, that was my process. Here, this would be an initial thing, and then go into why are we doing this, and then where do the signals come from? And we've got pictures of WWV and CHU, and we've got the pictures of the receiver. We've got pictures of FL Digi actually monitoring WWV. We got pictures of the Doppler shift plots, and then pictures of time of flight. And that's kind of the approach I took. So maybe you can weave some of those in there.
I absolutely do believe I can weave these in here. I think I very much believe I can weave these things in there.
Okay.
Yeah.
But
no, and I also believe that the other things that you've sent me by email, I can weave those in there as well. So
well, the thing is, many hams have heard about WWV, but they've never seen that picture of it, and they've never seen their antennas. I know I overdid the antennas, yes.
Yeah.
But there's plots for both WWV and CHU showing the facilities and the antennas, stuff like that. And because amateurs are always interested in antennas, especially around here.
Yeah.
I mean, that's a hot topic around here.
Yeah. Yeah.
But then, this goes to people who aren't amateurs.
Yeah. Yeah. No, I agree with that. But I do believe we can weave all of these things in there.
Well, take a look at the stuff in that Word document. Let me know if I can send. I don't really have a lot of other different slides. And I don't have any pictures of me or me putting the thing together. And this was done long before the AGU presentation came up.
Let's
and I do credit John. John put together a very nice little simple receiver.
Yep. Yeah. I agree. Let's see. Yeah, here's your. I have got your.
Okay, and I think that's your slide, the second one down.
Yeah, that came from my paper.
Right.
So I'm gonna hit you. I'll do one page.
And that set the stage.
Mm-hmm.
And actually, how long have ionospheric waves been recognized?
TIDs, they go back, to the 30s or 40s, I think.
Oh, okay.
They go back a while. And with SuperDarn, they've been studied. The first paper from SuperDarn looking at them, I think, is from 1989.
That's the WWV high frequency plot. Oh, I just threw that in for the heck of it. The Centennial.
That's cute. Yeah.
CHU.
And
you can see the 3 antenna plots. One to the right. And by the way, that's an unmanned operation. The only time there are people there is when they have troubles or need to check up on things. and one of their antennas. They all use verticals.
Did you get these off of, where did you get these photos from?
Those are off, that one is off Google Earth. The one
Okay.
below it, I forget where I got that one. But that, I don't think that's Google Earth. I think I just found that on the internet somewhere. And they're near audio. And here's John's schematic
Mm-hmm.
and a couple of printed circuit boards.
Mm-hmm.
A bill of materials.
Mm-hmm.
Had to buy a much finer tip soldering iron to do a better job.
Yeah.
There's all the parts to make one. I couldn't find the PCB. It's lost somewhere around here.
Mm.
Little machinist vise to hold it.
So, yeah, okay. So this is perfect. Like this is exactly, you know, the sort of picture I was like when I was saying pictures of you making it. This is some of your like personal.
Well, and it's interesting because it shows, I mean, as hams, essentially, if you look at the Grape One, you know, you're asking people to go out, spend their own money to do something for science, and they're doing it because they want to be helpful and they're interested in it. And I think that's what's very interesting about this project. And, you know, yes, you know, you may have to buy some new equipment, learn some new things, be frustrated some, but it shows that there is the motivation for, you know, citizens. Now, of course, many of these ham so-called citizens are actually, you know, electrical engineers and no more than, you know, some of the so-called professionals, but there's a real interest. And I think that's what, you know, some of these presentations about the citizen science aspect is about, is how as a non-scientist investing your own resources into a, you know, getting someone tenure, you know, how does that go? And you know, what works well, what doesn't? And those are important because I think there could be a lot more projects like this.
Yeah, this is perfect.
This is
the
the image of it. That's operating. That's actually receiving WWV. And
Yeah,
it gives you an
this
idea
is-
of how large it is. It's a quarter.
Yeah, that's like a perfect type of photo to include.
There's the grape and the GPSDO. WWV, FL Digi, right from the that's a screen grab off the operating computer, real time. Oh, by the way, what that shows, it shows the center locked to the carrier, the 100 hertz either side of that, and then off to the standby. My throat's I've constantly got a cold or something here, but it shows the I think that's, what is it? I think 500 and 600 hertz tones, and the voice announcement in the middle going across the middle of the scope horizontally across the display.
Right there.
So that's changing from 1 minute to the other, changes the tones from 600 to 500 hertz. And there's a lot of information in that display, plus a whole bunch of other artifacts. So there's results. It's pretty hard to see the electrons whizzing around in the receiver.
Yeah. No, that looks really good.
So there's that.
Because this is 1,000, 2, 3, 4. Is it 1,
2, 3, 4, 5. And
So
you can see the 100 hertz also beating on either side of the tone. Everything's mixing.
Yeah.
Lots of mixing going on there. And then all of these vertical lines, a lot of those have some multiple of 60 hertz. So I've got something running around the shack that's not real good.
Right. Yeah, this is a very good figure.
And there's a description. Here's a relatively quiet day. That was July 9th, I think. Yeah, 7-9.
Right.
There's a quiet day. And here's the one I keep talking about. There's the quiet day on the upper left. And then I think that's your one on the right. John's on the lower left, and mine on the lower right. All the same same time. That's the only time I could find more than a couple of slides. So you're what? You're 14 or something?
Me?
Yeah,
I'd
your
have to
node.
double check.
Where is that?
There's 14.
Yeah, I think that's you. I think that's
Yeah.
your plot.
Maybe and see. Yeah, I'm 14.
Okay. And I could have, but didn't throw. Oh, and there's a plot of what we have, and we need stuff up here in the Northwest. Hey, we had a Minnesota person on tonight. Can we talk them into setting up a
Oh,
grape?
yeah.
We can sure use that. And then your students need to get on there and find somebody down in Florida.
Yeah, they do.
And perhaps somebody out in California also. But it's
This
a
looks like a-
concentration between me
This-
and Maine.
Mhm. This looks like a good geometry right here. We're doing the type of analysis Veronica's trying to do.
Okay.
Right there. Because it's
Yeah.
in a triangle.
Right. I understand.
Yeah.
And if you were to get somebody in Florida, then you could put in Steve and me. And there are those timing pulses. And there's what happens some of the time. This is just simply a 500 microseconds per division, where the other one's a millisecond.
Yeah.
There's a millisecond. And there's some verbiage about the actual timing. Now, Steve and I did a fair amount of stuff back and forth, finding out that by the way, I can generate one of these ticks. If we ever need to do that, I can generate that. I've got an arbitrary waveform generator here.
It looks like you see it drifting down there.
That's very common. Yeah. But what counts is where it crosses the center line. You see where the center line is? And if you look very, very carefully at that, it goes down and then comes up, it comes back down. And that's key right there. And then over at the left is that vertical pulse from where I inject 1 PPS into the grape.
Right over here.
Yes, that is extremely precise.
Okay.
I mean, it's within nanoseconds.
That
And
comes
here
from the GPS.
It coming through the it's from the Leo. I think that one's from the
Leo
Leo.
Bodner.
Yeah, and that's good to I don't know, I think it's less than 100 nanoseconds accuracy. I have another one that's good to 5. And if I need to, I'll use that one.
Yeah.
So there's some results.
Yeah, this is great.
And there's what happens much of the time when you get, a double sideband AM with constructive or destructive interference called fading. There's a whole bunch of references.
Okay, great. Yeah, I think well do. And I may not get this tomorrow, or I will get to it before next week, but I'm like extremely crunched in terms of time with certain.
Cannot imagine end of the semester and getting ready for AGU and
it's absolutely unbelievable.
No, it's pretty
But-
busy around here too. I understand.
But no, I really do think I can work with this, and I think we can get it into a.
Well,
a
I
good
didn't
format
realize
for
what
next
you
week.
wanted. As I say, that first slide was a presentation to a verbal presentation. That was the
Right. I think this
And-
is good.
And some of the, one of the people especially put up a picture of his finished board that the guy's excellent workmanship, just
Yeah.
excellent. And we're using both CHU and WWV. There's the plot, the high frequency antennas. There's a 15 meter, 15 meter there. I don't know you want all the antennas,
Yeah.
but that shows a
But
bunch
definitely
of
some
antennas.
of them.
I think I would like to show where the signals come from, and
No,
the
I
fact
absolutely agree.
these are the authority. These are not just good. These are the world authorities for
Yeah,
time and frequency.
I absolutely agree.
Now CHU isn't quite as sophisticated. They don't have the budget, but WWV sure does, or NIST sure does, and that was just a cutesy thing. I found that
Yeah.
somewhere. But that's Google Earth.
Okay.
And it's unmanned building, 3 antennas. They do what, 3 something and 7 something and 14 something megahertz. And off to the left of that, there is the food inspection station. The Canadian food inspection station is across the road. See the road over there on the extreme left?
Over
On
here?
the other side of that road, it's the National Food Inspection Agency or something like that.
Huh.
That shows up on Google. And this is what, southwest of, I think, Ottawa. But I'll be using these to talk to the local club. We're having trouble finding people to present stuff.
Yeah, that'll be good to show them.
And that receiver has so little time delay that you don't even have to worry about it.
Yeah.
It is just almost instantaneous.
And David sent me his presentation too.
Okay, we'll throw a couple of those in.
Let's
And
take a look at it.
he's also listed on this, isn't he?
Yeah.
Okay, super.
We've got a lot of people listed on this thing.
Yeah, I noticed.
Oops. Yeah.
There's a couple of good pictures.
Yeah.
I would stick those in place of definitely in place of the one where I just show a couple of the bare circuit boards.
Yeah.
But although that was a place to start, that's what John provided.
Yeah, exactly. And well, I think that's the thing we want to show. We want to show that progression. Like we want to show going from
concept.
Yeah, concept. We want to go from like the bare circuit boards like this, and we want to get up to this sort of thing, and then you have it put together, and now you can actually show it.
Oh, by the way,
operating.
Not only a small tip soldering iron, but 015 solder really helped. Stuff's expensive. 15 bucks for just a quarter or eighth of a pound of it or something. What burned to death on that preceding one?
Where did you see that? Burned to death?
Oh, something burned to death, burned up. Oh, okay, here we go. Power LED stuck to iron burned to death. Oops. Okay.
Oops.
My problem was getting the, go back to that preceding slide. There's a little tiny electronic static discharge gadget, lower left-hand corner, just almost right next to the connection, the antenna connection. There's an ESD down there that is impossibly tiny.
Let
The right
Not
hand.
here, right?
On the other side.
Oh, on the
Yeah.
other side.
Yeah.
Is it
Little
that
right there,
one?
right there. Yeah. That thing, it took a microscope for me to get that thing placed.
Huh. Yeah.
Yeah, that little D1 thing. That's tiny.
Yeah.
Yeah, that's that SOT diode. Yeah, that's the smallest part on that board.
The only way I could get that on there was to drop it on the board and keep pushing it around until I could finally get it over the pads, and then kind of stick one to one and then solder the others. That was a challenge here. I'm not used to surface mount.
Mm-mm.
Can't see my antenna. Doesn't photograph.
10 megahertz dipole.
Yeah, I've got a 80 meter. That's my main antenna here. That's one I use for all sorts of other stuff, which means when I get on the air for nets and things, I have to disconnect that one. Plus, all my antennas are close together, so I would overload, especially if I fired up the kilowatt.
This is a nice figure showing nodes 22, 8, and 26 all lined up, so you really see how they're right next to each other.
That was what, 3 different stations?
Yeah. So I guess it's probably David Wow, Bob Benedict, and is node 8. Maybe that's John Gibbons.
Yeah, 22, 8, I think is John.
Because they're all located in the Cleveland area.
Yeah, okay, well, they would be similar. I have very
Yeah.
different signal strength out here, but I'm also getting Hawaii.
Yeah.
In fact,
Yeah.
at night, I suspect I'm getting Hawaii only.
Yeah.
I'm not sure how anybody would sort all that out.
See, what day is the actual poster session?
13th or something.
It's Wednesday the 15th.
15th, okay.
Okay. So here's our
list.
Our list, yes.
Yeah, there's Dave.
Yeah. We got Dave and Bob Benedict's on here too. So they're both Gary and Jim.
What more do you need from me?
I think, why don't you let me work
Okay.
with this for a little bit?
Okay,
And
got
then
it.
what I'll do is I'll get it into, I will redo it into a form that I think will be good for AGU. And then I'll send it back to you and Dave and I guess Bob Benedict and the other co-authors. And then you guys can be like, I think we should add this or change this, or you can kind of give your comments on it after I get it into like the right format. But
Okay.
I'm gonna work with the material that you sent me already and the material that David sent me.
I can't promise I have anything significantly different, but if you want another image of some kind, at least ask.
Okay. I think I have enough for now.
Okay, I suspect so too.
Yeah,
There's a whole story in there.
exactly. Right.
And
yeah, exactly.
And as I say, this is what I would be presenting to the local club, which is what I thought I was going to do at AGU.
Right. Which you are, it's just you're doing it in the form of a poster, not.
Yeah, I understand. I did not understand that at the beginning.
Yeah. Yeah. And I apologize for the confusion. And I guess this is where I'm kind of running at
Whatever.
the, yeah. So,
anyway.
but thank you. Yeah.
So-
I will work on this. As I
Okay.
said, I may have to prioritize making sure that my DSP class is in order first.
Yeah.
But
well, yeah, your professional stuff is
yeah,
kind of
yeah.
important.
Well, yeah.
Okay. Now
This is-
you've got the thing posted, right?
Yes. So
Okay.
you are.
So
we
not
don't
worried
have to worry about
tomorrow.
any deadlines for tomorrow.
Okay.
So that's all taken care of.
We just need to put together something neat that other people can use.
Right. Right. That's right.
And by the way, I'm very accustomed to answering questions by email.
Okay, that's great. So yeah, on the poster, wherever that went to, on the iPoster, there's a way that you can specify, you know, there's a way that people can email you with questions.
Yeah.
So wherever that.
I can't do any analysis, but I can certainly tell them how it went together and how to operate it and the problems I've had, which really are quite few. Biggest
That's
one was
great.
QRM from the 5 and 10 megahertz frequency standards.
Mhm.
And I just simply disconnected them, and I had them running all over the shack, powering various things.
Yeah. Yeah. That makes sense. Yeah, no, thank you very much for your help with this.
Well, appreciate your putting it together in a good format.
Thank you. We all work together. So I think a lot of my job is kind of being an integrator of this sort of information.
Management.
Yes. Yes.
That's much more valuable than people like me who just provide inputs to the manager.
Oh, no.
We're all needed.
We are all needed. None of this happens without.
Yeah, been there and done that.
Yeah. Okay. Well, I think I really do appreciate your help. I will be happy to go through this over the next few days and get into a format that I think will be well received by AGU. And then I'll be in touch and we'll go from there.
Super. Thank you, Nathaniel.
Thank you. Appreciate it. So I guess everyone else, anything else for tonight?
Most likely not.
All right. Are you feeling better, Scotty?
Yeah, a little bit. We started the house last week.
Yay.
And
How is it?
Well, it's good, but I spent too much time tramping around out there in the sun, and it was just like, after not feeling well, that wasn't something I should have done. So, but getting over it, trying to get back into getting something accomplished. I have about 4 jobs now that all require FPGAs, and I can't get any. So I don't know. I'm just going to go back to bed, I think.
So we're not the only ones.
We're not the only ones.
I've been following some financial stuff, and what's happening is the cheaper ICs are becoming in very short supply.
Yeah, like the ones we use.
Yeah, well, the dollar ones. And,
I see.
And this is holding up everything. This is causing a great deal of trouble. It's not just the expensive ones which are a problem.
Yeah.
What has happened apparently is the various factories, or what do you call them? Wherever they make these things.
Foundries.
There we go. They've been concentrating on the high end, high dollar, high profit items, and the inexpensive $1.50 chips that we need to glue everything together have kind of fallen by the wayside.
Yeah. Well, I heard online, I haven't actually found the story, but I heard that someone opened up a brand new foundry in Texas.
Mm-hmm.
A big foundry, which is a good deal. They're actually TSMC, the people who build FPGAs for Intel, the smaller FPGAs. They're working on a huge factory in North Phoenix. But these lines take years to bring up to speed. So it's like not going to be anything that's going to be short term. But I'm just kind of at a loss, because it's like in 2019, pretty much you could get anything you wanted whenever you wanted, just order it.
Yeah.
And now all of a sudden you can't get hardly anything. And I don't know where all these parts are going, because the production should be up to where it was in 19. So is the demand really that much higher? And where are all the parts going? Somebody's getting them.
I heard that one of the problems was the auto manufacturers expected to sell far fewer vehicles, and so they backed off on their orders, and the foundries making parts for them switched over to other items.
Yeah.
Are we also seeing hoarding on the manufacturers?
Somewhat, yes.
But do
I've seen gray market stuff, selling for big bucks because they've got it and you don't.
cars use FPGAs?
No, but they use lots of they use lots of other processors and support parts.
Yeah.
Guy approaches you on the street, opens his overcoat. Psst, extra watches. How
Yeah.
about ICs?
Used to be stereos, right? And now it's ICs.
Yeah.
But yeah, so I don't know how this is going to play out. But when I mean, as a hardware guy, I'm really kind of screwed over because I can't really pitch anything to any of my customers because if, like, for instance, we have a customer now we did a design for 2 years ago. And so for a piece of medical equipment, now they're ready to do a Rev C. Well, we did a Rev B board for them. We actually, it's a long story why there was no Rev A, but there was a Rev B, which is the prototype. And then they say, okay, well, we want to build like 100 of these now because we want to do more testing.
Okay.
And it's got an FPGA in it. And there's actually a TI part, also a voltage regulator. And we can design out the voltage regulator and design a different one in with the board relay out, but I can't design out the FPGA. I mean, there's no substitute. So if I could find one in a different package, I could do that. If I could find a little bit bigger one, they might be willing to go a little bit more money for that. But we're using a Max 1050, so it's the biggest one already. We could actually maybe use a 10M40 or a 10M25 if we could get it in the right package. But I can't get any of them. So what do I tell my customer? Sorry, go away. I mean, and a customer, an ongoing business outfit that tells me, we make ICs, we'll ship your order in December of 2023. That you're fired. I can't build product like that. So I can't buy their parts because I can't explain to my customer how we're going to be 2 years waiting for them to be delivered. So and the part of the problem is it's not like I can say, oh, well, forget you, Intel, I'm going to go to AMD. I'm going to go to your competitor and I'll buy from them because they got the same problem. And in fact, I heard actually AMD is talking about, and I don't know how far along it is, they're going to buy Xilinx. So there's really 3 FPGA manufacturers: Intel, Altera, Xilinx, and then a very small player. It used to be Microsemi. Now they're owned by Microchip. Well, now Xilinx is going to be bought up by AMD, and guess who's the 2 big chip CPU competitors? Intel and AMD, right? So now the 2 big guys who are making computer chips have probably very little interest in FPGAs other than what they can steal and put on their CPU dies. So I'm thinking what they're trying to do is they're trying to make some of their CPUs customizable using the FPGA technology. And they don't really care about FPGA standalone stuff like that we use. So if that's the case, when both the big companies get bought up, this is going to be a world of hurt. It's going to be time for me to retire because I won't be able to make anything. That would be like, I guess, like in your case, they would say, well, we're going to keep the university open, but all the classrooms are closed. Oh, wait, that's like it just was, with everything was virtual. But it would be like they would say, okay, Nathaniel, we want you to teach all of your classes, but you're not allowed to use any textbooks. It's like, no, the things that you need are required.
Yeah. It's like, how do you expect us to do this?
Yeah. I mean, how do you expect me to build anything that has an FPGA in it if I can't get the part?
Today, it's not textbooks, though. It's like, if I'm not allowed to use computers in my class.
Yeah. There you go.
Computers are so much
the same kind of thing, though. I mean, it's so ingrained in the course. It's not so necessary. You really have to have it.
Yeah.
So, and you can stand up there and wave your arms and half your students will be asleep because they don't have any hands-on, and then they graduate and they don't know how to do anything because you didn't have the equipment for them to actually work with. And you can't graduate them with no experience and just dump them into the workforce and say, here you go, be productive now.
Mhm.
And I mean, that was one of the things that Motorola did really well in the early days of microprocessors in the 70s and 80s,
Mhm.
is that they paired up with the university and they said to ASU, here's free dev kits, here's free ICs, here's anything you want. Here's what, and what they got in return was a whole years of graduating EE students that were experienced with Motorola products.
Mhm.
So they could hire them and they could go right to work in their labs and they could build example circuits, and they knew how the stuff worked because they studied it. And so it was an incredibly cheap investment on Motorola's part for an incredibly rich reward that they got. And I don't know what happened to that. It's just like they forgot how that worked. Of course, Motorola doesn't really do ICs anymore. So I mean, I guess there's some. It's now it's NXP and onsemi, and it's split off into a whole bunch of companies. But On Semiconductor's still here, and NXP's here. They make processors, so they could do the same kind of thing. Work with the ASU, but I don't see that happening.
Gotti?
Yeah.
I just posted a link you may want to take a look at. It's the future of Intel and FPGAs.
Oh, where did you see this?
It's on a high-end server website, but that's what they want to do.
Yeah.
It's a single board with a Intel processor and an Intel FPGA doing high-speed 100 gig internet.
And then Agilex part, that's $1,000 part or more, probably. I mean, it's a high-end. Look at the buses it's handling.
Yeah.
It's a memory interface and comms interface, high-speed comms. So
DDR4, probably PCIe, 2 100 gig interfaces.
Yeah, and so the problem is this business unit that does this is so much gigantic compared to the FPGA unit that they don't really care about Max 10s anymore. They're just like the little guy on the side. It's the guy making 7400s, when the big guy's making CPUs.
I'm just wondering when Rochester Electronics is going to start stocking some of this stuff.
I'm gonna check out. I'm starting to fade.
Okay.
Thank you, everybody.
7-3, Nathaniel.
7-3.
Good luck
And
with the.
I may not be here next week. I'll see how AGU goes, but
Yeah, I'm jealous you get to go to a live conference. Have a great time. You want me to notify the New Orleans authorities before you get there or after?
Why don't we let them find out for themselves?
Okay.
Surprise is often the best, right?
It's the best. That's right. Get you into less trouble.
Thank
Good
you.
evening, everybody.
Have a great evening. Thank you, Joe. Thank you, everyone.
7-3. Thanks for that link, James.
Sure.